Hello everyone. In today's video, we'll be talking about recursion. So let's start with the basic definition of recursion. So recursion is nothing but a function calling itself, right? So think of it as a puzzle, and to solve that puzzle, we break down the puzzle into smaller puzzles, and then we take one of those small puzzles, and then we break it down further into smaller puzzles. Essentially, we break down a big puzzle into so many smaller parts such that we reach a smallest puzzle after which it cannot be divided further. And then we solve that smallest puzzle and then we make our way upwards, right? It might sound confusing at first, but once you get the concept in your head, it will be very easy to understand what I'm talking about. Okay, let's take an example. Let's say we want to find the sum of n numbers. Okay, so sum of n numbers would essentially be 1 plus 2 plus 3 and so on plus n, right? So this is nothing but sum of n that we want to find. That's represented as like this. But we know that this can also be written as 1 plus 2 plus 3 plus so on plus n minus 1 plus n, right? So essentially what we are doing here is this is rewritten as sum of n minus 1 plus n, right? Similarly, this we will further break it down. That is, we'll make it 1 plus 2 plus n minus 2 plus n minus 1. Alright, so this can again be written as sum of n minus 2 plus n minus 1, right? So now we keep doing this until we reach a point where we are doing sum of the first number, that is this 1, sum of 1. So further below this we can still divide it, we can still divide this puzzle into smaller puzzles, which is it will go up to sum of 0, then it will come to sum of minus 1, similarly minus 2, minus 3. But we are not worried about these because we don't care about these. We just want to find the sum of n numbers, not considering the negative numbers, right? So this is our last puzzle that we can solve. This is the smallest puzzle that we can solve. We know the value of this is going to be 1. So we use this value in the previous puzzle and then we calculate the answer to that previous puzzle. Then we go back to the previous puzzle. Then we use this answer here. Similarly, we keep going back to the topmost problem, that is sum of n, right? So this is how we will be using recursion. Meaning, let me explain with the help of code now. Okay. Now, let's say we are writing a function sum of n, right? Before giving you the code, let me tell you that there are three basic concepts in a recursion that you need to be aware of. The first is called the exit condition, meaning if we are going to be writing a recursive function, we know that a function calling itself can go up to infinity, meaning a function can end up in a situation where it keeps calling itself. Considering this same example, if we did not stop here, if we did not stop at sum of 1 equals to 1, meaning if we didn't know that sum of 1 is equal to 1, it will keep on going further down. It would go up to sum of minus 1, sum of minus 10, similar sum of minus 1000. So there is no stop to it. But knowing this value, sum of 1, we know that this is our exit condition, right? Once we reach this, we need to stop going recursively. We need to start coming back to the functions that did recursion, right? So that is nothing but our exit condition. The second part is called the recursive call, right? This recursive call is nothing but what we do here. Sum of n minus 2, similarly sum of n minus 3, right? This is nothing but called the recursive call. And then the last condition is the calculation that we have to do. Okay. Now, calculation is nothing but this part of the code where we use the recursive calls sum and add it to n, right? Okay, now let us continue with the code. So I'll be able to explain it in a better fashion. Let's say we need to find the sum of n. So the first thing that we need to look into is the exit condition. So our exit condition is nothing but if n equals to 1, right? Then we are going to return 1, right? If n is 1, then we are going to return 1. Otherwise, the next thing, this is nothing but our exit condition. Okay. Then we look at the recursive call. Okay. Our recursive call will be nothing but splitting the problem into smaller problems. That is, we'll be doing here sum of n minus 1, right? And then the third thing is the calculation. So the calculation will be this recursive calls value plus n, and then we return it. Okay. This might look a little confusing, so let me just write it with the help of text here. Let's switch to text. Okay, so we are doing sum of n. Increase the text box size. Sum of n, and then we are calculating if n equals 1, then we are going to return 1. Otherwise, we are going to do the recursive calls value, which is nothing but sum of n minus 1. Then we are going to do the calculation, which is recursive call value plus n. Then we are going to return calc. All right. I hope this makes sense. Let's take an example of for this function. Okay. Let's consider we are trying to calculate sum of 5. Okay. So n value is equal to 5, right? N value is 5 now. Coming here, it will do this. If n is equal to 1, false. So it comes to this line, which is we are doing a recursive call of sum of n minus 1. So now we are doing sum of 4, right? Now again it checks if it n is equal to 1. That is wrong. Here n value is 4. So it goes back and it does sum of 3. Similarly, it does sum of 2. It checks if n is equal to 2, that is false. It comes back here and then it does sum of n minus 1, which is sum of 2 minus 1, which is nothing but sum of 1. Now when it reaches this particular function call, here it comes to this line and it checks if n is equal to 1. This condition is satisfied, so we are going to return 1, right? So now this calculates to 1, which is then returned to our previous call. So previously we stopped here because we went to sum of 1 from when we were in sum of 2, right? When we were trying to solve for sum of 2, we reached this condition and then we simply switched to sum of 1, which means we did not execute these two lines for sum of 2. But now that sum of 1 is calculated, meaning we have the value of sum of 1, which is equal to 1, we come back to our sum of 2 loop, sorry, sum of 2 function, right? So now that if we are in sum of 2, just a minute, now that we are in sum of 2, we know that we got the recursive call value as 1, right? Now we calculate this recursive call plus n. Here n value was 2. So this becomes 1 plus 2, which is 3. So sum of 2 value becomes 3. Then this is returned back to this. Again, we were in sum of 3 and then we called, then this recursive made us call sum of 2, whose value we now have is equal to 3. So RE's recursive calls value is 3 now. Then we go and calculate this recursive call plus n, which becomes 3 plus n, 3 plus 3, which becomes 6. So this value is 6. This is then returned back to our previous loop, which is sum of 4. Let me erase this up. Now we come back to sum of 4. So when we were in sum of 4 call, this particular line made us call sum of 3. Now that we have the value of sum of 3 equals to 6, we can continue our execution from this line for sum of 4. That will be recursive call value sum of 3, which is equal to 6 plus n. Now n value is 4, which is equal to 10. So this function returns the value 10, right? Similarly, we go back to the function, previous function call, that is this. Then we do sum of 5. So when we were in sum of 5, we were forced to call sum of 4, whose value we now have to be equal to 10. And the next line is trying to sum these two values up, that is 10 plus the n value, that is 5, which is equal to 15. So there is nothing to go back to. So this is our result. Sum of n equals 15. Okay, I hope you got this.